Hi, everyone. Sorry to be back for section 6.3. Just a quick add-on. There's something I forgot in that video, which I'm afraid might happen here and there as I do this through the year. Just a quick add-on. It's the idea of doing probability with replacement versus without replacement. So I'm going to do a quick example here. These are a little bag full of marbles. There are 2 pink marbles, 5 blue marbles, and 6 green marbles. So you probably remember questions like this from back in 4th grade or something, and they might ask something like, what's the probability of getting, if you're going to pick twice, getting a pink and a green? Clearly, it makes a difference of whether you put that pink one back in when you pick, right? So if I pick the pick first, it's going to be 2 out of 13, if I can add 2 out of 13. But then the green one, I got 6 green left, but did I replace, did I not replace, makes quite a big difference, right? Because if I replaced, the green ones would be 6 out of 13. But if I didn't replace, it'd be 6 out of 12, which is going to change the idea. So it's a pretty important idea. However, in our problems, you don't have to worry about this. In our problems, they're going to tell us who's going to change the problem. So you would change the multiplication. So you could either do 2 out of 13 times 6 out of 13, or 2 out of 13 times 6 out of 12, depending on which one they said. In general, if you have a really, really big population, so let's say you had 10,000 marbles in there, which were the same ratio, 13,000, or 2,000, 5,000, 6,000. Whether you replace or not, it's not going to make a difference. Think about how small. So if you had 2,000 now out of 13,000, and then either, there's still 6,000 green ones, right? It's either out of 1,300 or 1,299. You can see it's not going to make a big difference. So a lot of times we just ignore that idea if we have big populations, which is what most of the stuff we're going to do in this class is. I just wanted to mention those 2 ideas because there's like some card problems. What's the probability of picking a heart and a king, and then whether you replace or not is very, very important. Oh, and speaking of that, that might help too. Real quick, if you don't know the deck of cards, there are 52 cards in a deck of cards. All right. There are 13 hearts, spades, diamonds. I know most of you probably know this, but if not, you're going to need these clubs. The hearts and the diamonds are red, and the spades and the clubs are black. It's going to come up here and there. And then every suit has ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, and 2. Those are the 13 cards. So you might need that in doing card problems. So that's it. Sorry for the tack on. We'll see you later.